Hello everyone. In this short video, we are going to study about a very commonly used interfacing IC 8255. 8255 is also called as programmable peripheral interface. So in this video, we will be seeing about the basics, the block diagram and the modes of 8255. It's a very short video, don't skip it and see it. And in part 2 of this video, we are going to see how to program this 8255. Okay. So now what is an interfacing IC? So these interfacing ICs are a part of the microprocessor base system. So we have already seen what is a microprocessor and 8086 block diagram and its programming you have seen. So now 8086 will be the central processing unit, or it will be the brain of a microprocessor base system, but it cannot work alone. Okay, so this CPU, it cannot work alone as a standalone system. So it needs supporting ICs, or it needs supporting devices, so that it can be used as a system. Okay, so like a family, it will be having any other things which will encourage it and which will be putting this microprocessor based system into a particular application. Okay, so a CPU from microprocessor cannot work without memory. So usually ROM will be part of the system, and then you will be having timers, and you will be having serial port communication, parallel port communication, and this parallel port communication is done by an IO port. Okay, so IO port is meant for reading and writing from the input-output devices. Okay, so these input-output devices cannot be connected directly to a microprocessor. It has to be connected through ports or via something. Okay, so that via something, that is called as the interface. So when I take this diagram, this blue diagram, okay, it shows just an example of what are the interfacing ICs which could be connected with 8086 based microprocessor system. Okay, so all these ICs, whatever I have shown here, are compatible with 8086 because they are all from Intel family, or these 8086 is the microprocessor from the Intel family, and now you are having surrounding that supporting interfacing ICs which is meant for particular applications. So the main application is to read and write from the data communication, okay, from input output devices. So this 8255 is called as programmable peripheral interface, which could be used to read data or write data through the IO ports which is available in 8255. So in this video, we are going to study the block diagram, how many ports are available, what are the modes available for 8255. Okay, similar to 8255, you are having many other peripheral ICs which could be connected to a microprocessor system, to a microprocessor to make a microprocessor system. Okay, so 8253 is a timer. Okay, that video is also available. And then 8279 is a keyboard interface, and then 8259 is the interrupt controller, okay, to manage the interrupting signals, and then DMA data transfer. To manage that, you have one IC called as 8257. So these are all dedicated ICs which will be supporting these particular functions, okay, as named here. Okay, apart from this, you will be having latches and buffers and memories and so on. Okay, so this is a very rough diagram where I have shown only the data bus which are all bidirectional, and we will be having many other ICs which will make one microprocessor based system. So now we are going to study about 8255, which is called as programmable peripheral interface. Okay, so this programmable peripheral interface can act as an interface between the microprocessor, okay, and the IO devices. So the IO devices can be simple switches, or it could be relays, or it could be sensors, it could be display units, it could be simple LEDs, or it could be 7-segment displays, or it could be LCD display or some other display. Okay, many kind of sensors and printers, all those things can be IO devices. Okay, so these IO devices may be slower than this 8255 and 8086. So these may be slower, or sometimes it may be in the same frequency. It could operate at the same frequency also. Sometimes, most of the times, it is slower. Okay, so now this IO devices will be having a data, okay, or byte, and it can be read by 3 ports, or read or written into by 3 different ports of 8255. So you are having 3 ports in 8255, port A, port B and port C. They are all 8-bit ports. Okay, and now this from the input device, the data will come to 8255, and from 8255 the 8086 will read it. Okay, so now this, when this 8255 is saying that I have a data, then this what is it, the data bus, there will be a data bus buffer, and from there this 8086 will read it over the data bus. Okay, so this acts as an interface between the IO device and the processor. That's why it is called as an interfacing device. Okay, now we'll see what is there in the block diagram. What is there inside this? So it is a programmable IC. Okay, it could be used for outside world, where you have analog to digital converter, digital to analog converter, keyboard. Okay, what is it? Other sensors and so on. It could be programmed. This 8255 can be programmed, or it could be configured. Okay, in different modes, and it can be connected with almost any microprocessor, TTL compatible, with any TTL compatible devices. Okay, and then it is having 3 bidirectional IO ports, which are named as port A, port B and port C. So there are 8 into 3, 24 IO pins. Okay, and which could be individually connected into 2 groups of 12 bits each. Okay, and there are 3 different modes of operation, and it could be used for any 80 Intel compatible devices. Okay, so okay, the same thing we are seeing it again. So port A, 8-bit port, it could be used as an input port or output port. So when it is an output port, the data will be latched. Latch means it will be going through a latch. You can put it in a latch, and then from the latch it can read. Latch, you know, flip-flops and latches, you know. Okay, similarly when a data is read, it will be buffered. It will be put in a buffer. Okay, similar to this, port B is also there, and port C is split into 2 parts, port C lower and port C upper. Okay, so 4-bit, a lower 4-bit port and a upper 4-bit port. So PC0 to PC3, that is pin numbers 0 to 3 of port C is called as lower port of C, and then 7 to 4 are called as higher port of C. Okay, and now these could be, so the grouping we will see that. And now there are 2 major modes. One is called as IO mode, another one is called as bit set reset mode. Okay, so there are few more modes in this IO mode. We will see that in the coming slides. Okay, so now this is the block diagram. So now this ports are the main thing in 8255. So in this there are 3 ports I told. No, each port is having 8 bits. So port A is having 8 bits. So port A and the upper part of port C are together called as group A. Okay, so group A consists of port A and the upper 4 bits of port C. Similarly, the lower 4 bits of port C and port B are called as group B. So these 24 pins are divided into 2 groups of 12 bits each. Okay, so for all these things you are having a control. So group A control, group B control, they are all logic which will control this. This is the internal data bus, 8-bit internal data bus. These are all data bus. Okay, and the single lines are control lines. Okay, now here on the other side you have a data bus buffer. So you have a 8-bit data bus buffer. Buffer means where you have the data stored for a short time. Okay, so that is called as a buffer. So you have a data bus buffer, and the data bus buffer is connected to the microprocessor. Okay, so this bus will be connected to 8086. So 8086 may send data to any of the ports, so that will come through the data bus buffer, and then it will come through the internal bus and to any of the ports as mentioned by the 8086. Otherwise, when you are reading from here, the ports will read it, and via this it will come to the data bus buffer. From the data bus buffer, the 8086 will read, the microprocessor will read it. Okay, and there is one logic called as read-write control logic. So this read-write control logic will be will be receiving control signals from microprocessor, which are read bar. Okay, you have a bar, then low logic, and then write bar, and then a reset. Okay, and then chip select. CS is chip select bar, which will select the whole chip, and then you are having two address bits. So A0 and A1 are the two address bits. Okay, so these are the signals for the control logic. From here, many more control signals are internally generated and given to the parts of this 8255. Okay, so this pin diagram, 8255, 40 pins are the ground VSS. Okay, chip select bar, read bar, write bar. Okay, and then two address pins, and then rest are only the ports. Okay, so PA0 to PA7, PA0 to PA7, and then PB0 to PB7, PC0 to PC7, and you have data bus. Okay, so this D0 to D7. Okay, so actually 8 into 4, 32 pins will go only for the data, only for these ports and the data. Okay, so its block diagram is very simple. Okay, very simple. The signals are also very simple. Okay, so this, as I already told you, pins of port A, pins of port B, pins of port C, data lines. Reset is an input from microprocessor. All these things are inputs from microprocessor. Okay, so reset will reset all the internal registers of 8255. Okay, so this is a global reset which will be received by 8255 from the microprocessor. Okay, now modes of 8255. So actually there are two modes. Okay, generally there are two modes, IO mode and bit set reset mode. This bit set reset mode is exclusively for port C. Okay, so in the IO mode you have three other modes which are called as mode 0, mode 1 and mode 2. Okay, so in mode 0 all the ports will be acting as simple IO ports. That is input, either input or output port. So port A can be either input or output. Port B can be either input or output. Port C, there are two separations. So port C upper can be individually input or output. Similarly, port C lower can be individually input or output. This is called as simple IO mode. Okay, and then mode 1 is called as handshake mode. Okay, so strobe mode or handshake mode. Here you will have some handshaking signals. Okay, and this mode 1 is available for port A and port B. So this port A and port B can be used as an input or output, and there can be some handshaking signals. Handshaking signals means there will be a protocol, that is the device may say it is ready. Okay, and then it may say strobe signal. Okay, and signals between the IO devices and between your input buffer full. So these signals are there between the IO devices and microprocessor and this 8255. So this is handshake signals. These handshake signals will be used from the bits of port C. Okay, so we need not go detail into this because it's out of the scope of your thing. You will use simple IO mode. Okay, and then but know what is what. So mode 2, in this mode port A can be used as a bidirectional port. So port A can can read and write simultaneously. Okay, that is, it can be configured as a bidirectional port, and port A uses 5 signals from port C as handshake signals. Okay, that is handshaking or for the data transfer, status signals and signals are from port C. Okay, the remaining 3 signals of port can be either input or output, or it could be used by port B also. Okay, so now okay, so now coming to the control word and so on. So now you have 2 address bits A0 and A1. So what is the purpose of this A0 and A1? So this A0 and A1 are address bits. They are used to select any of these four, that is port A, port B, port C, are control register. So there is one internally there is one register called as control register, a 8-bit register. So what is written into this 8-bit register will control the whole 8255. That's why it is called as control register. So in order to write the control word into the control register, you need to select it. Okay, so when these two bits are 1 and 1, the control register will be selected. Okay, when it is 0 0, port A is selected. When it is 0 1, port B is selected. 1 0, port C is selected. And for all these selection, chip select should be 0. So chip select 8255 itself is selected only when chip select bar or chip select is 0. Okay, so when it is 0, all these things work. If it is 1, it is no selection. Okay, otherwise 8255 is not at all selected. Okay, now you just for example I am giving, suppose if the processor is using a 8-bit address for the what is it, 8255. Okay, so for these ports, if it is using an 8-bit address, there is an option to use a 16-bit address also. Now let us assume that it is in the IO mapped IO method. So it is using a 8-bit address. So suppose it is given that, assuming that port A is having an address of 80, then automatically you will come to know the addresses of the other what is it, other things, port B, port C, port control register. So if this is 80, it will be 81, 82 and 83. Okay, according to this. Okay, so according to this. So now there is one more thing to be understood, but it is difficult for you to understand. That is the chip select signal. The chip select signal is produced from the address bus only. Okay, so depending on that, suppose if this A0 and A1 are connected to some other bits of 8086, okay, then this address may not be consequent like this. It may be what is it, 80, 82, 80, 84, like that also it can go. Okay, it will be what is it, plus 1 if A0 and A1 of 8086 is connected to A0 and A1 of 8255. Otherwise this will be different. Okay, okay, now leave it. If you understand up to this, okay, that is fine. Okay, so now you have to study about the control word, because for programming that, which is given in part 2 of this video, you need to write the control word and then only you can configure your 8255. Okay, so now I told there are two modes. One mode is called as bit set reset mode. This is applicable only for port C. Okay, that means any bit of port C you can set or reset. What do you mean by set is you can make a particular bit of that port C as 1. Okay, making that bit as 1 is called as setting. Making the bit as 0 is called as resetting. Okay, so now you can make any of the bits of any of the pins of port C either 1 or as 0. Okay, so now for BSR mode, in the 8-bit control word, the first bit will be 0. Definitely it should be 0, then only it is BSR mode. Okay, and the next 3 bits are not used. Okay, and then the next 3 bits are for the bit selection of the port C. So if this is 0 0 0, PC not is selected. If this is 0 0 1, PC 1 is selected, and so on. Okay, and here this last bit, no, it will specify whether you are going to reset that bit or you are going to set that bit. If it is 0, you are going to reset. If it is 1, you are going to set this bit. Okay, so this is the control word for BS. This is only to set or reset any particular bit of port C. Okay, okay. Now you are having one more control word, which is called as IO mode control word. Okay, so the control word format for IO mode, simple. IO means for data transfer. So here the other ports are also involved. In BSR mode only port C is involved. Okay, so now for IO mode, this D7 must be 1. Okay, for BSR mode this D7 should be 0. for IO mode this D7 must be 1. Okay, and then the next 2 bits are for mode selection of A. Okay, so port A can work in mode 0, mode 1 or mode 2. So 3 modes are possible for port A. Okay, so if it is 0 0, port A is in mode 0. If it is 0 1, it is in mode 1. If it is 1 0 or 1 1, it is in mode 2. Okay, so the next 2 bits is for the mode selection of port A, and the next bit controls port A's IO function, that is whether it is input or output is determined by this D4, this bit. Okay, so if this bit is 1, then it is input. If this bit is 0, it is output. Okay, 1 means, okay, 1 and I. Okay, 1 it is input, 0 it is output. Okay, so 0 and O is similar, no? So 0 means it is output. Okay, so this will determine the IO function of this, and then next one will determine the IO function of port C upper. Okay, so the first MSB 4 bits of port C is determined by this, by either input or output, the same thing. Okay, IO function, 1 means input, 0 means output, and then this bit is for mode selection of port B. So port B can operate in 2 modes, mode 0 or mode 1. Okay, so this single bit is used for mode selection of port B, and then this is, it will define whether port B is input or output, and then this will define if the port C lower is input or output. Okay, okay, so this is these are the modes. Mode C, mode 0 is all the ports are simple IO. Okay, mode 1 it is called as handshake IO or strobed IO, that is you are using some handshake signals. Okay, so in this mode either port A or port B can work as simple input port or simple output port, and port C bits are used for handshaking signals. Okay, so the handshaking signals are strobe, acknowledge. Okay, and then if this is busy, okay, or not. Okay, so acknowledge busy will be coming from this starting to strobe it. Okay, to enable it, CPU will give a strobe signal. So these signals will be going through port C. Okay, so port C will be used as handshaking signals. So this is for an output operation. Okay, similarly for input operation you have some 3 pins of port C for the handshaking signals. So this is called as mode 1. Mode 2 is a bidirectional only for port A. Okay, and 5 handshaking signals are required, that will be given by port C. What is it? That pins will be available in port C. Okay, so these are the 3 modes of operation of 8255. Okay, so thank you, and please see the next. This video is only for people who are absent for the last class, and the next video will be for everyone. Okay, thank you.